Hello, good afternoon. Welcome to Fourth International Congress on Human-Computer Interaction, Optimization and Robotic Application. FORA 2022 is organized by National Technical University, Kharkiv Polytechnic Institute from Ukraine. FORA 2022 is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support to FORA 2022. That's if you want to start the session. First paper belong to dear Afnan Mohammed. Are you ready to present? Dear Afnan Mohammed.
I think Afnan Mohammed not here.
Okay. Dear Ali Saadun Ahmed.
Yes, Doctor.
Okay. If you are ready, you can start your presentation.
I'm Ali Sadun Ahmed or
Ali Saadun Ahmed.
yeah. Okay. Okay, I am ready.
You can start your presentation if you are ready.
Okay. Just a minute, please.
Teacher, I think Afnan Mohammed came to this room.
Yes, sorry, I was in another room.
Afnan Mohammed.
Yes, I'm here.
Okay, if you are ready, you can start your presentation before.
Okay. I can share my screen.
Okay.
Okay, sir, I'm waiting.
Okay. You have 10 minutes, please, dear Afnan Mohammed.
Okay. Hello, everybody. This is Afnan Mohammed. We made this project, me, Safar Rifai, and Gino Zamir. I am a fourth-year student in Istanbul Cultural University, and our project is about detecting phishing website using machine learning. Our supervisor is Professor Dr. Uzgur Kuray Shahingoz. So first of all, this is the outline of our project. First, we are going to have our introduction. What is phishing? Why do attackers use phishing? And then we have our related work. Then we have our implementation. Last, we have our conclusion and our future work. So first of all, phishing attack is a simple way to obtain valuable data and personal information from the attacked users. There are many available methods to detect phishing, but also many other ones are being invented every day. The aim of our project is to detect phishing website using machine learning in order to decrease the amount of phishing. And in order to do so, we trained our data with 9 models, which we are going to talk about later. So first of all, what is phishing? Phishing is a form of fraud in which an attacker steals valuable information of the user. So for example, as you can see in this diagram, the victim enters a legitimate or a usual website, and then a pop-up link shows on the website, which is occurs to be a phishing website. And then when the user clicks on the link, he's taken to the phishing website, in which the attacker then steals the user's information and uses it in order to log in other benign websites. There's also another common form of phishing, which is phishing emails, in which also malicious links and attachments are shared. Some attackers extract login credentials, and others also steal account information from the victim. So why do attackers use phishing as a form of stealing information? Because it's far easier for them to steal information than breaking through the computer's defense system. These are some of our related works. So we did a research about other forms of about phishing websites, about detecting phishing websites, and most of them are 2019 or later. So for example, the first dataset has a paper which used used the dataset from UCI. It has 11,055 phishing websites and 30 features, and the reach accuracy was 97.4 to 97.576%. So as you can see, most of the results are high in this field, the accuracy results. So now we have our implementation part. First of all, the machine learning part, which consists of the dataset. So our dataset was collected from Kaggle, which has 11,430 URLs and is also balanced since it has 50% legitimate website and 50% phishing websites. It has 87 extracted features, 56 are extracted from the URL's syntax and structure, 24 is from the corresponded pages, and then 7 are extracted from external services. Now we have the training model part. So we trained our model using the following 9 machine learning algorithms. First, we have decision tree, then we have random forest, XGBoost, AdaBoost, gradient boosting, k-nearest neighbors, multi-layer perceptrons, naive Bayes, and support vector machine. So before we start on the algorithms, there are some terms we should know. First of all, we have precision, which is the quality of positive predictions made in the model. As you can see, this is the precision formula, which is true positive over true positive plus false positive. And then we have the accuracy, which is the percentage of correct predictions for testing the data. Lastly, we have recall, which is the how many of the true positive were recalled in the data. So as you can see, this is a diagram to compare the accuracy and precision. The data is at its best when both of the precision and accuracy is high, but also accuracy is more important since when the accuracy is low, the data is not that accurate. The first model we use is decision tree, which is a supervised learning technique. It's mostly used for classification, but it can also be used for regression. And it's a tree-structured classifier in which the internal nodes are the features of a data set, the branches are the decision rules, and each leaf node has the outcome. It had an accuracy of 93.7%, precision of 94%, and recall of 93.4%. The second model is random forest, which is also a popular machine learning algorithm. It also uses supervised learning technique. It's also used on the concept of ensemble learning, which combines multiple classifiers in order to solve a complex problem and to improve the performance. We reach an accuracy of 96.4% and the precision of 96.9% and recall of 96.4% using random forest. The third algorithm, which is XGBoost, is an implementation of gradient boosted decision trees. It is designed for speed and performance that is dominative competitive machine learning. And we reach an accuracy of 96.4% using XGBoost, a precision of 96.5%, and a recall of 96.3%. Then we have an AdaBoost, which is an ensemble learning method. It is initially created to increase the efficiency of binary classifiers and uses an iterative approach in order to learn from the mistakes of weak classifiers. So we reach an accuracy in this model usually of 95.3% and a precision of 96.3% and a recall of 94.4%. Then we have gradient boosting, which is a group of combined machine learning algorithm. It combines many weak learning models together in order to produce a stronger predictive model. It uses decision trees and controls both of bias and variance aspects. It is considered to be more effective than other Bayesian algorithms. And we reached an accuracy of 96.4%, precision of 96.5%, and a recall of 96.3%. Then we have our key nearest neighbor algorithm, which is one of the simplest machine learning algorithms. It also uses a supervised learning technique. So the process of this algorithm has two parts. First, it assumes the similarity of new cases versus available cases, then puts the new cases into the most similar categories to the available cases. So we reached an accuracy in this model of 83.2%, precision of 89%, and a recall of 76.2%. Then we have multi-layer perceptron, which relies on neural networks in order to perform classification. And the neurons in this model are trained using backpropagation learning. This model is nonlinear and it consists of 3 layers. So the first layer is the input layer, the second one is the hidden layer, and the third one is the output layer. The input layer gets the signal in order to begin the training. And the hidden layer is made up of many layers and contains the main engine for the machine learning. And the output layer is in charge of the required task. So in our case is detecting if the website is phishing or not. And we reached an accuracy of 81.1% using this model, a precision of 96%, and a recall of 65.3%. Then we have naive Bayes, which is a supervised learning technique based on Bayes algorithm. It's used for classification problems, and it's one of the simplest and most effective classification. We reached an accuracy of 73.8%, precision of 69.2%, and a recall of 86.8%. Then we have our support vector machine, which is also a supervised learning algorithm and is used for classification and regression problems. The goal of this algorithm is to create the best decision boundary, and it can segregate n-dimensional space into classes, and it makes it easy to put the new data point in the correct category. So we reached an accuracy of 59.6% and a precision of 56.3% and recall of 89.5% using this algorithm. So this is a comparison between all of our 9 models. So as you can see, the best train accuracy, test accuracy is for XGBoost, which is 96.4%, and then the lowest accuracy is for support vector machine, which is 59.6%. So in conclusion, in this project, we use machine learning methods in order to decrease phishing website success rate by increasing the detection rate of them. Our dataset was from Kaggle, and it was 50-50 ratio. So 50% of it was phishing and 50% of it was legitimate. And we also trained our dataset with a 50-50 ratio. So 50% was for training and 50% was for testing. We had 11,430 URLs and 89 total features. We use 9 machine learning models for training our data, which are XGBoost, gradient boosting, random forest tree, AdaBoost, decision tree, k-nearest neighbors, multi-layer perceptrons, naive Bayes, and support vector machine. And our results show that the best algorithm used was XGBoost, which had the highest accuracy of 96.4, recall of 96.3, and precision of 96.5%. So for our future work, we intend to increase the accuracy of our data, of our training and testing, by increasing the dataset size and deploying other models and creating our own dataset. And we also intend to make a website with a better view and work on the website structure. So that's it for our project.
Okay. You finished your presentation?
Yes, I did.
Okay. Thank you for your presentation. Dear participant, do you have any question about this paper? Okay, no question.
Yes.
Thank you again.
Thank you.
I wish you success.
Thank you.
Dear Ali Sadun Ahmed, are you ready to present? Ali Sadun Ahmed, are you ready to present? Okay.
Yes, sir. Yes, sir. I'm ready.
Okay. Okay.
Mhm.
You can start your presentation. You have 10 minutes, please.
You can see presentation, Doctor?
Yes.
Okay. Hello, everyone, and very good afternoon. I will introduce myself. I'm Ali Sadun Ahmed from Iraq, master student in Altenbusch University under Information Technology Department. I will explain my paper, Quantum Computing, title, Quantum Computing and Artificial Neural Network for Classification and Time Series Prediction. Outline of this presentation: introduction, research problem, research objective, solution proposed, conclusion, and feature. In this slide, introduction, I will be define machine learning and neural network, a machine learning approach of computer science that focus on developing numerical architecture and algorithm that teach a machine how to perform a specific task. It is subfield of artificial intelligence, image identification, speech recognition, classification, and text translation are some of the common application of machine learning. The neural network, abstract computation model, derived from an understanding of the pairs neural processing system. They are used in artificial intelligence application, bio-based neural network. Okay. The next slide. In this slide, I will define quantum computing as a model of control manipulations of information contained within the state of a quantum system that has been developed. That is the extension of classification competition model. with module manipulations of information content within binary starting as they occur in the real world. Both computational module include various methods of storing, transferring, and measuring information. Quantum computing provide normals being filed for device, algorithm, characters, and wide range of inclusive by splitting the binary function as shown in figure 1. Next slide. This is a distributed key function. You can see this figure. A neurons model, this figure an artificial neural network architecture consider a biological approach that is exercised in the multiple language with of processing unit nodes. Elementary processing units are killed in neurons. You can see in this figure. Okay. Research problems. The time delay additive evaluation method TAEF is modern time series prediction method that performs an evaluatory search for at least the number of dimensions required to explain the fundamental information that you generate from the time series. Next slide. Research objective. You can explain research objective in 3 points. To correct for temporal phase distortion. Number 2, to find the best fit model for chain predictions. Number 3, to begin with, then performs a behavioral statistics test. Solution proposed. In this slide, you can explain the solution proposed. For the solution of this problem, we can turn the parameters value should be turned to find the best value that is challenged. Sorry. The search for a proper explanation trade-off remains. A challenge takes a task, and any optimization process. Next slide. A conclusion. The proposed solution is impaired by the partnership of taxing and the constant of the intelligent hyper. Model consists of artificial neural network with genetic algorithm modification to current to temporal phase distortion. The TC model find the best fit model for chain prediction to begin with, then performance behavioral statistics test. An explanation study was carried out according to many performance metrics. The robustness of the method is shown by comparing previous findings found in the literature, and this opting by more differential approach. Next slide. Feature work. You can see this feature works. The Netherlands implementation focusing on abstract model. We found the express protocol used. Next, we introduce a quantum telefunction as a simple technique for transferring quantum information without the physical transfer of the particle, the whole quantum information. It outlined a key research problem for the creation of a quantum communication networks. To solve this problem, several materials, the optimization algorithms have been proposed. One of the modern algorithm is the PAT algorithm, PA, has successfully solved many problems, but has not been applied to deal with a quantum artificial problem. Thank you for listening, and any questions?
Thank you for your presentation. Dear participant, do you have any question about this paper?
Thank you for listening. I
Thank
really
you.
appreciate your cooperation with me. Thank you, sir.
Thank you. Thank you. I wish you success in your career.
Thank you, sir.
Dear Eftekhar Jamel, are you ready to present?
I think she isn't here.
Okay. Dear Mohammed Mustafa,
Yes, I'm here, Doctor. Iftikhar.
you can start your presentation if you are ready.
Yes, I'm ready.
You have 10 minutes, please.
Okay. I'm Iftikhar Jamil from Iraq, a master student in Altenbash University in Istanbul. My subject fog and the cloud load balancing using regression-based recurrent deep learning algorithm. Presentation outlines, introduction, research problem, contribution, proposed method, and conclusion. The introduction, the problem of saving energy and controlling the temperature of computer has been around since the appearance of the first computer. With the increase in processing capacity, computer components consumed more energy. Furthermore, with the chips becoming more compact and containing increasingly dense circuitry, the release of energy in the form of heat increase. This means even more energy consumption as computational components don't operate well at very high temperature and therefore are cooling system. Decision makers should be made aware of the security problems associated with the cloud computing so that they may make educated judgments. In this figure, we explain the cloud and fog and Internet of Things users layers. Research problem. Due to an increased network latency, traditional cloud-centric network application deployment failed to provide a quick response to many of the time-critical applications, such as healthcare, emergency response, and traffic surveillance. Here, along with the remote cloud, the fog have limited computational resource to provide a quick response to time-critical application. In this figure, we explain the processing speed and the response speed time between the layers, the cloud, fog, edge, and Internet of Things. Contributions. We design an architectural system model for the data-driven deep reinforcement learning-based scheduling for fog cloud environment. We outline a generic learning model for scheduling in decentralized environment. We demonstrate a residual recurrent neural network based framework for exploiting temporal patterns for scheduling in a hybrid edge cloud setup. We show the superiority of the proposed solution through extensive simulation experiment and compare the result against several baseline policies. The proposed method, we assumed that the underlying infrastructure is composed of both edge and cloud nodes. The fog cloud environment consists of distributed heterogeneous resources in the network hierarchy, from the fog of the network to the multi-hub remote cloud. The computing resources act as hosts of various application tasks. These hosts can vary significantly in their computer power and response times. Computational resources, the fog devices, are closer to the user and hence provide much lower response time, but are resource constrained with limited computational capability. On the other hand, the cloud resources, virtual machines, located several hubs away from the users, provide much higher response time. However, cloud nodes are resource enriched with increased computational capability that can process multiple tasks connected. This is the MATLAB setting parameters. Simulation and result consist of the parameters of host, which include utilization and capacity of CPU, RAM, bandwidth, and disk. It also includes the power characteristic, cost per unit time, million instruction per second, MIPS, for the host, response time, and the number of tasks to which this host is allocated. Different hosts would have different computational power, CPU, memory capacity, RAM, and input-output availability, disk, and bandwidth. This is the modeling of network architecture. And this is the service allocated, the proposed system. Optimization strategies. This section describes optimization strategies in response to autonomic event in the fog computing environment. In this context, two types of event are defined in the scope of this work. The second case happens when the application model needs to be migrated to other node to meet some defined QoS objectives. GA algorithm scheduling. The current state of an application can be represented by a checkpoint, which is then restored to the source node and the exact moment the checkpoint was made. During the experimentation process, the projected network characteristic for the public and the private networks setup will allow for real-time data collection due to the natural of the network tools, which are discussed in greater detail in the following subsections. Conclusion. As an alternative of traditional computing for latency-sensitive application, this master thesis presents fog computing as a viable option. The paper discussed fog computing, including its advantage and disadvantage, as well as its theoretical basis and related search findings. Fog nodes, they employed the Dockers and the CRIU, checkpoint live restore containers to assist in the implementation of optimization strategies. Thank you. Any question?
Thank you for your presentation. Dear participants, do you have any question about the article?
Thank you for all.
Okay, no question. Thank you again. I wish you success in your study.
Thank you so much.
Next paper belongs to dear Muhammad Mustafa. Are you ready to present? Dear Muhammad Mustafa. Okay, the next one. Dear Maryam Al Hussein.
Yes,
Are
I'm here.
you ready to present?
Yes, I'm ready.
Okay, you can present if you are ready.
Okay. Hello, everyone.
You have
my
10
name,
minutes, please. You have 10 minutes, please.
Yes. My name is Mariam Ali Hussein Al-Balhawi, and I am from Iraq. And my supervisor name Ghalib Kansivar. And my title subject is intrusion detection in IoT networks using feature selection and SVM classification. Introduction. Since the last decade, Internet of Things, IoT, Internet of Things branches of society, such as the solutions for transport and urban communication. For example, this way, IoT is a new paradigm which is composed of a global network of machines and devices capable of interacting with each other. IoT changed the
Sorry,
you
your
hear
voice
me?
is corrupted.
Do you hear me?
We can't hear you.
Do you hear me, sir?
We can't hear you.
Do you hear me?
We hear you. Yes. Okay.
Can you
You
hear
can
me?
continue,
sir?
please. You can continue, please.
Okay. Problem, in spite of the maturity of IDS research, the present IDS solutions are insufficient for widespread use in IoT implementations. For example, a common security hole is that devices use very weak passwords or even standard passwords. A strategy used by malicious agents and botnets. They are composed of an organized network of infected devices which can receive attack orders. Therefore, IoT security is an issue that deserves attention. Highlights a projection that point up to 26 billion IoT devices will be connected to the internet by 2020. Therefore, it is necessary to develop approaches that can guarantee IoT security. Objectives. The object of this work is to develop a model to identify DDoS infiltration, web, and brute force attacks on computer networks, using machine learning techniques, increasing the accuracy, sensitivity, precision, and measurement values in relation to existing work. Build a more comprehensive and current data set with DDoS infiltration, web and brute force attack in a real environment. Apply feature selection techniques in order to reduce the dimensionality of the set, increasing the speed of attack identification. Contribution. A new intrusion detection system has been proposed and implemented in this project work, which combines a feature selection algorithm and SVM technique to detect attacks. Using KDD CUP dataset and data mining, extract the hidden predictive information from large databases. It is a powerful new technology with great potential that helps companies focus on the most important information in their data warehouses. Data mining can be applied to any kind of information repository. Why we choose IDS? The purpose of IDS is to help the computer systems to deal with attacks. This anomaly detection system creates a database of normal behavior and deviation from the normal behavior to trigger during the occurrence of intrusion. Based on the source of data, IDS is classified into host-based IDS and network-based IDS. In network-based IDS, the individual packets flowing through the network are analyzed, whereas in host-based IDS, the activities on the single computer or host are analyzed. The feature selection used in IDS helps to reduce the classification time. Materials and methods. IoT, the Internet of Things, IoT is a concept that is having a lot of success nowadays, and everything is due to the expectation generated by being able to connect any object to the internet and do whatever you can think of. The possibility of assigning computing capacity to everyday objects and giving them a certain intelligence to collect data from their environment and communicate with each other can create numerous applications that can completely change people's life. Although it seems that we are talking about something that has been with us for a long time, giving its popularity in recent days, the reality is that it's a very recent concept. IoT security challenges. In IoT, there are several security problems, and this is due to characteristics and specific facts, which are outlined and are. Interdependence, a characteristic that consists of many devices interacting with each other, and in some protocols, the actions of a device are directly defined by the behavior of other devices. Diversity, as there are many communication protocols in place of IoT, it is difficult to solve security problems for all of them. Machine learning. The field of machine learning is concerned with the question of how to build computer programs that automatically improve with experience. That is, acquire new knowledge, skills, and techniques for organizing knowledge. According to since the computers were invented, the question of whether they could learn was present, because if it were possible to understand how to program them to automatically improve with the experience, this would be a great advance. Learning consists in the development of methods that are capable of extracting concepts from data samples. Therefore, it is a process by which the computer, their descriptors and characteristics, defines concepts, and based on them is able to predict labels for new entries. Improvement and result. Data collection. The data collection agent collects the records from the KDD99 CAP data set. This data is sent to the data pre-processing model for pre-processing the data. The records collected from the KDDC. Data processing. Pre-processing techniques are necessary for data reduction since it is quite complex to process a huge amount of network traffic data with all features to detect intruders in real time and to provide prevention methods. SVM algorithm. SVM is the learning machine that can perform binary classification and regression estimation tasks. They are becoming increasingly popular as a new paradigm of classification and learning because of two important factors. First, unlike the other classification techniques, SVM minimizes the expected error rather than minimizing the classification error. Second, SVM employs the duality theory of mathematical programming to get a dual problem that admits efficient computational methods. How to improve SVM? The normal feature selection algorithms take large computation time for calculating IGR values. Hence, in this work, a new feature selection algorithm called optimal feature selection algorithm that reduces the time taking for computation is proposed and implemented. This algorithm calculates the information gain ratio IGR value for the varying attributes in the dataset. It performs a column reduction based on the IGR value. OFS increases the accuracy in detection and reduces the false alarm rates. Simulation. The simulation was carried out by using the IoT library in MATLAB R2020A. Although the library was initially set for cloud IoT, it was modified with a different dataset and attack using botnets. The library is open source from the link below. Dataset parameters. Attacks classification time. Conclusion. IoT networks have been widely used today in various branches of society. However, it is known that its characteristics have been exploited by malicious agents as weakness to orchestrate attacks. Supervised machine learning is an approach that can be used in the creation of tools that assist in the detection of botnets. In view of this, in the present work, a study was developed on the detection of abnormal activity in the context of IoT. This was done with the objective of analyzing the functioning of machine learning techniques active in these devices. Because traditional supervised machine learning techniques may not be visible in the contents in the context of IoT due to the high computational and human cost associated with the database labeling process. I'm finished, sir. Do you have any questions?
Thank you for your presentation, dear participant. Do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you, sir.
Dear Ehab, Ahmed, are you ready to present?
Yes, I'm ready.
Okay. You can start your presentation. You have 10 minutes, please.
Okay. Good afternoon, everyone. My name is Ihab Ahmed. I'm undergraduate student at Yıldız Technical University, Electrical Engineering Department. I will be presenting our work entitled Assessment of Overvoltage and Power Losses in Low Voltage Distribution Networks with High Photovoltaic Penetration based on prosumer self-conceptions. This outline I will be going through during the presentation process. Firstly, I would like to talk about the significance of the distribution energy resources. It's well known that distributed energy resources are pretty beneficial for either consumers and utility companies from different aspects. These benefits can be summarized in 3 points. Firstly, from environmental perspective, distributed energy resources plays a vital role in the reduction of carbon dioxide emissions. And from technical perspective, more flexibility is achieved thanks to the demand response programs and ESS, energy storage system, controllable loads. And finally, the prosumers can reduce their bills thanks to two-way energy transaction between householders and grid. So considering the aforementioned profits, the decision makers in developing countries has made new policies to encourage the consumers to become prosumers. However, there are some issues emerged with the integration of the distributed energy resources into the grid. For example, the stochastic nature of the distributed generation is making the integration is so hard. When a vast power injection to the grid is lead to an overvoltage problems, which endanger the power supply quality. So in response, several methods in the literature has introduced the way to deal with these problems. For example, active power management, reactive power control, and local voltage control strategy based on power curtailment. Moreover, the utilization of energy storage systems can increase the grid stability. So in this paper, we aim to investigate the impact of distributed energy resources on the voltage and power losses in the low voltage distributed networks. IEEE European low voltage test feeder is selected in this study. This distribution networks has almost 907 nodes with only 55 active nodes connected with residential loads. So we modified this network as follows. We substituted the 55 residential loads with 100 prosumers and allocated it randomly. And every prosumer has rooftop PV. So based on the fact that the voltage rise is experienced in the node farthest from the grid, 5 nodes are selected to be examined as shown in this graph. So here, the weather condition parameters given in the table in the site of Istanbul is used to calculate the PV power. So I would like to define the self-conception ratio, which we utilized here. a self-consumption ratio is defined as the ratio between the electrical power that generated and consumed immediately by the householder and the total power generated. So here, the PV load refers to the power generated and used to supply the load immediately, and PPV refers to the total generated PV power. So in the results section, we see the load profile and PV generation profile. PV generation profile is calculated via PV library. It's open source Python library. The parameters here is utilized to calculate the PV power, as I said before. So we calculated the PV power for 12 days. Each day represents 1 month with one-time resolution. Here in this graph, you can see the PV generation at node 886 with the self-consumption ratio 20%. This heat map shows the maximum recorded voltage for every SCR value from 10 to 65, as the allowed voltage variation range is between 0.95 and 1.1. It can be seen that the voltage constraint is violated here after under 25 SCR values. In this graph, the voltage fluctuation is given at node 886 for each value of SCR. We can see here as the SCR value increases, the voltage fluctuation is also increases. And the maximum voltage has reduced by 16.6 when the SCR increases from 10 to 65. This table describes the corresponding installed PV capacity and total energy, total power losses for each SCR value from 10 to 65. As the SCR increase, the load decrease, the losses decrease. However, after SCR is 55 and above, the loss increased again. This happens because the generated power reduced, so the householders is draw power from the grid. This graph shows the correlation between the SCR values and the total power losses. Actually, it describes the same table here. So we can see here that there is an exponential relationship between the SCR and the power losses. The power losses decreased exponentially as SCR increased. For a particular, after particular SCR, it's almost 55, the power losses start to rise again. So to sum up this presentation, the SCR below 25 at high PV installed powers in low voltage distribution networks and over voltage situation in the grid has started to occur. It was determined that the maximum voltage level decreased by approximately 16.59 as the SCR increased from 10 to 65. However, when the increase in the PV installed power of the generating consumer exceeds a certain value, above 55%, an increase in power losses is detected. This study will assess the future control management and planning of distributed production units with increasing numbers of prosumers. That's all. Thank you for your attention. If you have any questions, I'm ready.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Dear Kahir Hajar, are you ready
Hello?
to present?
Hello?
Hello.
Yeah, I'm ready.
If you are ready, you can present your study.
Okay. Hello, everyone. My name is Mohammed Khair Hajjar, and today I will be presenting to you.
You have 10 minutes, okay?
Okay.
You have 10 minutes, please.
Okay. Hello, everyone. My name is Mohammed Khair Hajjar, and today I will be presenting to you our study. Our study is about forecasting of Turkey's total electricity consumption in sectoral basis using machine learning algorithm. This study has been done by me and also by Dr. Elida Ol. In this study, we are going to discuss multiple subjects. First, we are going to start with the aim of the research significance, the previous study, research methodologies, implementation and results, and in the end, the conclusion. Turkey is considered one of the fastest growing economies in the world. And as the economy increases, the electricity consumption increases. So we are going to forecast the total and sectoral electricity consumption in Turkey using different machine learning algorithms for the time period in between 2021 and 2050. And then we are going to analyze the result to determine which of the methods that we use performed better. In order to forecast the electricity consumption, we are going to use Weka. Weka is a free software that uses machine learning algorithm for data mining. And we are going to implement different time series forecasting algorithms to reach a forecasting model that has a good and reliable performance. After researching previous study, it's found that the multi-layer perceptron and sequential minimal optimization have had a great success as a time series forecasting algorithms. So we are going to use the multi-layer perceptron and sequential minimal optimization to forecast the electricity consumption, and then we are going to compare in between them using statistical metrics. This will give us an idea about the future total and sectoral electricity consumption in Turkey. Multiple studies were made in India, France, Brazil, Bangladesh, and Turkey, among other countries. These studies used various machine learning algorithms to forecast the electricity consumption. The algorithms that were used are based on the artificial neural network and deep learning, such as the multi-layer perceptron, the sequential minimal optimization, support vector regressor, Gaussian regression, and more. And to evaluate the studies, the statistical metrics were used are the determination factor, the mean absolute error, the mean absolute percentage error, and etc. in order to evaluate the model's performance and to compare in between them. So in order to do this research, multiple steps must be made. First, we start by obtaining the data from TUIC. TUIC is the Turkish Statistical Institute. The data came as an Excel file, so in order to use the data in Weka, we are going to convert the data to attribute relation file format. And then we are going to import the data into Weka. So after that, a multiple variation of parameters were tested in order to find the parameters that prevents any under or overfittings. So then, after obtaining the best parameters, the algorithms with the best parameters were applied and the results were collected. Then, using the statistical metrics to determine the best model for each model, and for each sector. In this study, we are going to use two methods, two algorithms. First, we are going to use the multi-layer perceptron, which is based on the artificial neural network. The artificial neural network is a simplified emulation of the human brain, where there is a hidden layer in between the input and the output. And as for the forecast, as for the multi-layer perceptron model, Y is the output vector, phi is the activation function, WT is the weight vector transpose, X is the input vector, and P is the bias. As for the sequential minimal optimization, it's based on the support vector machine for regression, where the formula of it, the norm W is the norm for the vector, for the weight vector, the C is the penalty factor, and Xi is the non-negative slack value. And we are going to use the polykernel, where the kernel execute a nonlinear transformation by reducing the complexity of the word, where x is the inputs and p is the degree of the polynomial equation. So in order to do this research, we are going to create the ARFF attribute relation file format. By creating this file, we are going to determine the type of each attribute, where the year attribute were defined as a data attribute and the total and sector electricity consumption were defined as a numeric. Then, using the time series forecasting tool in Weka, by using the multi-layer perceptron regressor and sequential minimal optimization regression method to perform the forecasting data. In order to find the best parameters, multiple of trial and error has been done. In order to find the result that has the best parameters, so the results were compared for each attribute and for each algorithm by using the evaluation benchmark metrics. And when we find the best results, the algorithm with the best parameters were applied and the results were collected to perform the evaluation metrics to know which of these algorithms had better performance. The statistical metrics that we are going to use to evaluate our work is the determination factor R-square, which gives us an indication about the success of the model in tracking the trend. The mean absolute error will give us an indication about the long-term performance of the model. The mean absolute percentage error, when it's less than 10%, this means that we have an accurate model, a highly accurate model. When it's between 10 and 20%, this means that I have a acceptable accuracy of the model. When it's between 20 and 50%, when it's between 10 and 20%, we have a good accuracy of the model. 20 to 50%, it means that we have an acceptable accuracy of the model. Higher than 50, we have an inaccurate model. The mean square error we also use, as well as for the root mean square error and the absolute percentage error. The best parameters that we found, as for the sequential minimal optimization regression, as for the complexity is 22, the filter type uses the normalization of training data, the kernel function we use the polykernel, and the regression optimizer we use the regression sequential minimal optimization improved. As for the training and testing data dividation, for the commercial sector we used 70%, 30%, and for the others we used 80-20. The lag length indicates how many previous instances has a direct influence in forecasting the electricity consumption or in forecasting the instances. So, as for the commercial, governmental, household, illumination, industrial, and other sectors, we used 4 previous lag. And as for the total electricity consumption, we used 5. As for the multi-layer perceptron regressor parameters, we found that the momentum is 0.2 for all of them. The hidden layer value indicates how many nodes inside the hidden layer. As for the commercial, governmental, household, and total, we used 9. For the illumination, industrial, other sector, we used 10. The learning rate was between 0.3 and 0.4. The lag length has varied between 10 and 20, and it's presented in front of you. As for the results of the sequential minimal optimization data, after forecasting the electricity consumption between the years 2021 and 2050, as the actual data we had was in between the years between 1970 and 2020. So we found that the industrial sector electricity consumption at the year 2050 is to be around 328,000 gigawatt. For the commercial, to be around 38,000 gigawatt. For the commercial, it was 389,000 gigawatt. For the household, was around 150,000 gigawatt. For other sectors, it was around 45,000 gigawatt. For the governmental, was 33,000 gigawatt, and for the illumination sector was around 6,000 gigawatt. The other sectors here means the fishery sector, the private sectors, and also any other sector that have a small electricity consumption, all combined. As for forecasting the total electricity consumption, we found that in the year 2050, the total electricity consumption using the sequential minimal optimization regressor will reach around 953,000 gigawatt. But in summing the forecasted electricity consumption for the sectors, we found that the total electricity consumption will be around 777,000 gigawatt in 2050. As for the multi-layer perceptron regressor, we found that the electricity consumption will be around 170,000 gigawatt in 2050, 42,000 for the commercial sector, 91,000 for the household sector, 24,000 for the other sectors, 16 for the governmental sector, and 6,000 for the illumination sector. As for the forecasting of the total electricity, it's found that in the year 2050, it will be around 356,000 gigawatt. But when we sum up the forecasted sectors, we found that the total electricity consumption to be around 351,000 gigawatt. By evaluating the models, we found that for the commercial sector, the multi-layer perceptron regressor performed better than the sequential minimal optimization regressor, where the evaluation metrics had better values than the sequential minimal optimization regressor. For the governmental sector, we also found the multi-layer perceptron regressor had better values for the statistical metrics that used to determine the accuracy for the model than the sequential minimal optimization regressor. For the household sector, we found that the sequential minimal optimization regressor had better values as the statistical metrics than the multi-layer perceptron regressor. For the illumination sector, we found that the multi-layer perceptron regressor had better values as statistical metrics than the sequential minimal optimization regressor. For the industrial sector, it's found that the sequential minimal optimization regressor had better values in the statistical metrics that were used to define the model performance. And for the other sector, it's found that the multi-layer perceptron regressor had better performance in forecasting the electricity consumption for the other sectors. As for the total electricity consumption, we found that both models have had a great performance, as both of the evaluation metrics for both of the models had a good values. So we are going to use other statistical metrics that we are going to show in the next slide. As for the determination factor, the overall values of the determination factor for the multi-layer perceptron regressor was better than the sequential minimal optimization regressor. But as we found that the household sector and the industrial sector, as well as the total electricity, sector, the sequential minimal optimization had better values. And here, the determination factor for both of these mentioned sectors are almost the same, as both of them has values higher than 90%. Here, the total S means the summation of the forecasted electricity consumption for the sector, and the total F means the forecasted total electricity consumption. After looking at the tendency of the data, we found that sequential minimal optimization regressor had performed better in forecasting the total electricity consumption. So, by using the formula generated by WECA, we forecasted the electricity consumption for the years between 2011 and 2020, and we compared it to the actual data that we have obtained from TWEAK. So, by calculating the absolute percentage error, we found that the absolute percentage error was in between 0.03% and 5%. This indicates of the accuracy that the model have achieved. In the conclusion, we forecasted the total electricity consumption for Turkey for the years in between 2021 and 2050 using the time series forecasting tool in WECA. After evaluation, we found the multi-layer perceptron regressor performed better for commercial, governmental, illumination, and other sectors, where the SMO regressor performed better in forecasting the industrial and the household sector, as well as the total electricity consumption for Turkey. So both models performed good, but considering the tendency of the forecasted data and the evaluation metrics, it's found that sequential minimal optimization regressor gave overall better result in forecasting the total electricity consumption in Turkey. Thank you all for listening. This was my presentation. Any questions?
Thank you for your presentation. Dear Pasim, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Okay, thank you everyone, and I wish everybody a success in their career.
Okay, thank you. Dear Mia Mohammed Asif Sayed.
Hello. Can you hear me?
Hello. Yes, if you are ready, you can present.
Yeah, sure.
You have 10 minutes, please.
Okay. Good evening, everyone. I'm Mohammed Asif Said, along with my team members. We are from Bragg University, Dhaka, Bangladesh. So our research topic was flood prediction using machine learning model. So as you know, a lot of people outside the country that Bangladesh is a very Bangladesh is a country that where natural disaster occurs very frequently, and flood is one of the biggest natural disaster which happens almost every year in the country. So on an average, every year in Bangladesh, 18% of the country gets flooded, and during severe flooding, about 50% of the country gets affected. In Bangladesh, flood is divided in 3 categories, namely monsoon flood, flash flood, and tidal flood. And we work on monsoon flood. So here is a map. You can see the flood affected area of Bangladesh in monsoon season. And this is the intensity of the floods from 1954 and 1999. So the research problem, as you know, flood is one of the highly devastating natural calamities which causes serious social and economic losses. And according to the Economical Organization, flood causes around $40 billion damage worldwide annually. The Southeast Asian region is more prone to flood due to its geographical region. And due to this, Bangladesh is among the most vulnerable countries to climate change scenarios, mainly flood. So according to many research, like during the time period of 1974 to 2014, Bangladesh has experienced flood 78 times. This costed 41,783 people their lives, destruction of thousands of crops and many of their homes. And the main purpose of this research is to predict floods with a higher accuracy. A model will be proposed based on rainfall and flood data collected from the monitoring systems of Bangladesh Meteorological Society. And the dataset is then categorized depending on various parameters. After filtered the dataset, an appropriate column is chosen as a target for data modeling. So as most models deal with numerical values, the missing values and the categorical features are handled. Then we have trained the model, and our intention is to get maximum accuracy using binary logistic regression. So you can see the research methodology as we use the data set and the data cleaning with feature engineering, feature encoding, and feature scaling. And then lastly, we applied the model. Our main focus is on binary logistic regression, but to compare with other models, we used support vector classifier, k-nearest neighbors, and decision tree classifiers. So the data we used has been collected from Bangladesh Meteorological Society, and it has rainfall and flood data of 34 stations, which has been recorded each and every day since 1980 to 2020. So depending on the parameters, the data set is categorized and then feature engineering, and we use feature engineering and feature encoding is applied later. And ratio for partitioning the data set is 80 and 20. So I have said earlier that we used mainly binary logistic regression, and for comparison, we use support vector classifier, k-nearest neighbor, and decision tree classifier. The decision function has been made based on the accuracy and standard deviation. So as I have already said, we got data from Bangladesh Meteorological Society. So it has data for 34 different stations on each day of every month. And the station and it has the labeling flag, which said if we had flood on that year or not. So for dataset pre-processing, firstly we did data cleaning, then feature engineering, then feature encoding, and lastly feature scaling. For data cleaning part, we identified the inaccurate records from dataset and then removed the non-relevant parts of it. Lastly, the unequal days of each month were handled, as many months has 30 days in a month and many has 31 days. So in the feature engineering part, we calculated the monthly rainfall data and then we turned the months into our columns, and Lastly, we had the annual rainfall data and the flood level, if we had flood on that year or not. And for feature encoding part, as we know, we only can, most of the models only can handle numerical data. So we use binary values for the flood occurrence part. One for we had flood on that year, and 0 for we didn't have flood that year. So feature scaling, we use a standard scaler, and it is scaled with a unit standard deviation, as we know. And for the result, we used two timelines from the 1980 to 2020, the whole dataset we used. And in this timeline, we can see that binary logistic regression had 85.61% accuracy, which is among all the models we used. And it also has a very good precision and the highest recall, 55%. As you can see, the more classified reports here, you can see that the classic binary logistic regression has the highest precision and F1 score. And lastly, this is the confusion matrix of this timeline. Later, we used a smaller timeline from 2011 to 2020. As we know, climate change happens in a very long period of time. And mostly the older data does not give us a accurate results. So also in this shorter timeline, 2011 to 2020, we can see that binary logistic regression has the highest accuracy, 86.76%, and also the highest precision, 61.54%, and a highest recall score, 66.67%. So here are the classification reports, more detailed reports, and we also can see that binary logistic regression has the highest among all the models we have used. And this is the confusion matrix and the ROC curves. So lastly, for a conclusion, for machine learning models, we applied in the dataset, and we also got the better accuracy in the shorter timeline than the whole 40 years timeline. The performance of all four were compared in terms of accuracy, precision, recall score, is AUC score, and F1 score. For future work, we are trying to get data like water level, temperature, humidity, and other natural disasters from our government and Bangladesh Meteorological Society. So if we can get all the data, we will try to get more better results using our model. So that's it from me. Thank you.
Thank you for your presentation. Dear participant, do you have any question about the article? Okay, no question. Thank you again. I wish you success in your career.
Thank you so much.
The last paper of the session belonged to Nami Saleh.
Najmi Saleh. Yes.
Okay. Are you ready to present?
Yes, of course. I'm ready.
Nami Saleh. Okay, you can start your presentation if you are ready.
Can you see my screenshot?
Yes.
Okay.
You have 10 minutes, please.
Okay. Hello, ladies and gentlemen. My name is Najmi Ali Abdul Saleh. I study master degree of mechatronics engineering at Kujali University. My supervisor is Professor Hussein Mateen Ortonj. Today, I will talk about detection of air bubbles from tire chirography images. Outlines. Firstly, problem formulation, related studies, then objectives, proposed model, and experiments and results. Finally, conclusion and feature study. Problem formulation. Firstly, preserving human life. The air bubbles defects in tires are one of the reasons that cause a tire explosion, which may endanger human life. Decrease the significant amount of experienced human resources at factories and automation of the tire manufacturing process. Currently, the factories depend on experienced operators for the tire defects detection process. This process requires a significant amount of experienced human resources. And this process takes time and requires a certain cost So these factories need to automate the tire manufacturing process. Related studies, as I have read in the previous studies, there have been limited studies to solve the problem of detecting air bubbles. They have used machine learning techniques such as superfactor machine models and random forest models. Their results are presented here in this table. The random forest classifier achieved the best recall value of 96.32%. And the superfactor machine classifier achieved the best accuracy value of 95.76%. Objectives. There are two objectives. The first objective is build a novel texture features based on a model that can recognize the air bubbles from tire chirography images effectively and rapidly. The second objective is compared multi-layer perceptron, random forest, and gradient boosting models in the tire air bubbles chirography images recognition applications. Proposed model. Our proposed model included two stages. First stage is feature extraction, and the second stage is classification. Example of data. Actually, we collected and labeled our data I collected and labeled our data by experts from the Pirelli Automobile Tires Smith factory. Our data contains 1,000 chirography images. It divided into classes. First class is with air bubbles. Second class is without air bubbles. The first class contains 207 chirography images, and the second class contains the 793 chirography images. Those are symbols of chirography images with air bubbles. Those are air bubbles. And those are the symbols of chirography images without air bubbles. In those images, we can't see any air bubbles. Feature extraction. This stage concerns on transforming the input images from a matrix.
Sorry. Your first page is appeared on the screen. Your first page of the your presentation is appeared. Okay, now it's changed.
No?
Okay, continue, please.
Okay. Feature extraction stage flowchart. This stage concerns on transforming the input images from a matrix of pixels into a specific number of features. Those features are then used as inputs to the classification models and help to make difference between the categories of input patterns. Here, we started by converting the RGB image into the gray image. After that, we used three texture features extraction. The first, after that, we used three types of texture features extraction. The first type of them is GLCM. We have used the GLCM matrix of the image. After that, 24 texture features were extracted. The second type of them is GLSZM. We have calculated the GLSZM matrix of the image. Then 16 texture features were extracted. The third type of them is GLRLM. We have calculated the GLRLM matrix of the image. After that, 16 texture features were extracted. Finally, we transferred them into the classification stage. Classification stage flowchart. We started this stage by applying normalization and shuffling the data set. After that, we used the multi-layer version control and random forest and gradient boosting models for training. So each classification model was each classification model was trained for 30 independent runs and tested using 10 cross validation to study the stability and variance of the models. Experiments and the results. We have 3 tables for results. First table for classification.
Please change your slides.
Okay. Why this problem? I don't know. I'm sorry for that. Now?
Okay.
Okay. We have 3 tables for results. Firstly, a classification result for the GLCM features. The random forest classifier achieved the best recall value of 98.11%. And the best values of accuracy precision F1 score achieved by using multi-layer version table. Okay. Second, a classification result for the GLRLM features. The random forest classifier achieved the best recall value of 99.135%. And the best values of accuracy, precision, and F1 score achieved by multi-layer version. The third table is classification results for the GLSZM features. The random forest models achieved the best recall value of 99.15%. And the best values of accuracy, recall, accuracy, precision, and F1 score achieved by MLP models. Conclusion and feature study. A novel tire air bubbles chirography images recognition model is proposed. The best recall of the proposed model is 99.135% that it got from the random forest classifier with GLRLM features. Other kinds of machine learning models can be proposed. Other kinds of feature extraction techniques can be proposed. Finally, other kinds of deep learning models can be proposed. Thank you for your listening. Any question?
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. Thank you again. I wish you success.
You're welcome.
Dear Muhammad Mustafa, are you online? Okay. Dear participants, thank you for your attending. The session is over. I would like to end the session. I suggest you to attend the next session, which will start shortly 5 o'clock, at 5 o'clock. See you in the next session. Goodbye.
Goodbye, Dr. Goodbye. Goodbye, everyone.
Goodbye, Doctor.